We've seen blue. Now what's really missing here? What colors do we want? There are two colors we really want here and we really like here. What are those? Orange. Okay, look around. Orange. And what's the other one? Black. Okay, yeah. So the first experiment I'll do is going to be the iodine clock experiment. And I want you guys to focus on this bottle really, really hard to turn it into black. Alright, so that's what you have to do. Think really, really hard. I have two solutions here, and when I put them together, they should turn black. Maybe a little blue first, but certainly after that it's going to turn black. So let's see what happens. Are you thinking hard enough? Alright, let's see. Just making sure this is the right solution. Now I'm shaking. Okay, think harder. Still colorless. Okay, you're not thinking harder. Black, think black. Still not thinking. It's colorless. Okay, this is the color we want. Okay, I know that half the people are thinking colorless still. Black. If it helps, this color. Ooh. Alright, it took a while, but then you go hard enough, it does turn black. Okay, this is one. What else do we want? What's the other color? Orange, that's right. So, let me find the right bubble. And with this experiment, what I want to do is turn the solution orange, and then I quickly want to turn it into black, so that you can see both colors of the tigers. By the way, before we go on, let me just, in 2 words or 2 sentences, explain what is going on here. So in this reaction, we have a slow reaction that will go between one of the reagents and the very common one, potassium iodide, and then we have a fast reaction. What's going on here, whatever is formed in the slow reaction is quickly eaten up in the fast reaction. But when it's done, then suddenly the whole mixture of the reaction turns into the color, which is blue, but we have lots of blue, and that makes it black. And now, I'll do another reaction, which is very similar, except I add another ingredient, and that is mercury. And you know that mercury is very dangerous, so we have to dispose of this properly. And then mercury forms mercury iodide, which is an orange compound. So I'll be doing the same thing. I'll put the two things together. And now, what you have to do is think orange. Okay, so first you have to think orange, and then quickly think black. And if you maybe half the crowd should think orange, and half the crowd should think black, and everybody's doing their job, then we should see both colors. So let's see. Want to see it again? Actually, there's 3 batches of everything just in case one doesn't work. And sometimes that happens when I try one of the experiments in front of some of my general chemistry students on Thursday. One experiment just didn't work, and it didn't work. It was so embarrassing, it was the last class, and the experiment didn't work. And then I went back to the lab and tried it. And tried it second time, third time, still didn't work. It turned out that one of the ingredients was too old, and then when I tried it with fresh hydrogen peroxide, it worked. So, again, orange and black. That was probably enough orange and black. What you have to do is you want to see more orange and black. But come back here for Gabe. Okay. So, these experiments that happen after a certain time are very popular. Again, they're based on the slow reaction and the fast reaction. And one thing that we want to do is, can we turn the colors back? So we want to change the color, and then change the color back, and then change it forward, and so on and so forth. So we want to do oscillations. And for that, that was the reaction I tried to do in front of my students. I'll have a very large cylinder in which I'll be adding 3 solutions. And those 3 solutions will first turn the mixture orange, and then dark blue, and then back into orange, and it will oscillate for quite some time. So one of the key ingredients, and that's the hard one to get, and that's the one that goes bad fairly quickly, is hydrogen peroxide. Hydrogen peroxide, you can actually buy it in the store to minor cuts or disinfectant, but this is a concentrated one that only gets to that. And so first I will put this hydrogen peroxide solution into the cylinder, and then I turn on this stirrer, and I have a magnetic stirrer bar in there, and now there's a rotating magnet underneath it, and now I can stir the solution without actually touching it. And then I will add 2 other ingredients, one that contains malic acid and manganese, and the other one is potassium iodate. And when I need to start, so let's see what happens. Right, now it's orange. And suddenly blue. It's not, right? No, it's not. The first turning back into color last takes a little while. And now it's back into color. And then into orange. And then to blue. And then I go back.
That's a good one.
Hopefully. And it's colorless again. And it will actually do this for a very long time. So this is what we call an oscillating reaction. And it's a very special one where the concentration of the various species go back and forth for a very long time. So hopefully it works this time. Alright. So that was my part.